So Kekulé structure was unable to explain the extreme stability of benzene ring, which was later explained by the molecular orbital theory and resonance. We know that in the case of benzene ring there is presence of alternate single and double bond. Because of that, every carbon which is present in the benzene ring is having sp2 hybridization. We know that in sp2 hybridization there is planar structure. It means every carbon which is present in the benzene ring is showing sp2 hybridization. Because of that, this benzene ring is having planar structure. So let's see by the help of molecular orbital theory. So in the case of benzene ring, this is Kekulé structure. In Kekulé structure, these corners are representing the carbon. So every carbon is joined by one hydrogen. It means one hydrogen is bonded with each and every carbon which is present in the benzene ring, and this carbon, these all 6 carbon is having sp2 hybridization. Because of the sp2 hybridization, this benzene molecule is having planar structure, and angle of 120 degree is present between the two bonds in the case of planar structure. So how this hybridization, that is sp2 hybridization, is obtained? We know that carbon is having atomic number 6. What is the electronic configuration? 1s2, 2s2, 2p2. This is the outermost shell of the carbon. In this there is 2 electrons are present in the s subshell and 2 electrons are present in the p subshell. This is ground state. So what is happening in ground state? There is 2 electrons are present in the 2s and 2 electrons are present in the 2p. So in ground state there will be no bonding will takes place, because in this case there is only 2 unpaired electrons are present. So by the help of these 2 unpaired electron, this carbon will not complete its octet. In excited state, one of the electron of s subshell will jump to p subshell. So what is happening in this case? Each and every orbital is now having 1 electron. So because of the symmetry and equal energy, now these orbitals are hybridized orbital of this carbon. So when there is unpaired electron in each and every orbital of this carbon, so there will be pairing will takes place. So what is happening? This carbon is bonded by the 2 carbon, next 2 carbon and 1 hydrogen. So what is happening? This carbon is bonded by one single bond, that is sigma bond, and another pi bond with this carbon, and it is bonded to the sigma bond with this next carbon, and one sigma bond with this hydrogen. So what is happening? It means there is a bonding of one carbon with the sigma bond and another carbon with the sigma bond. It means there will be 2 sigma bond are formed with this carbon and this carbon. So there is a 2 sigma bond and 1 sigma bond will be formed with hydrogen. So it means in this case there will be pairing of electron will takes place between carbon and hydrogen, whereas this unpaired electron which is present in the pz orbital will overlap with the electron of this carbon. So what is happening? We know that when there is a bond, first bond will be formed between the 2 atoms. So this bond will be formed by the actual overlapping. So this is known as sigma bond, whereas second bond which is formed by these 2 atoms will be pi bond. So in this case what is happening? This carbon is forming one sigma bond. Further, when bonding will takes place between this carbon and this carbon, so that bonding will be pi bond. And we know that in the case of pi bond are not included in hybridization because they are not actual overlapping. So what is happening? How many sigma bonds are there? This is one sigma bond, this is second sigma bond, and this is a third sigma bond which is bond between the carbon and hydrogen, whereas this last orbital is forming pi bond. Because of that, the hybridization which is shown by each and every carbon is sp2 hybridization. So sp2 hybridization is obtained by each and every carbon. So because of that, this molecule, this benzene molecule is having planar structure. This is the one of the hybridized orbital of one carbon. If we represent this carbon, so this is one of the hybridized orbital of this carbon which is bonded by the hydrogen, and there is pairing is taking place. We know that this is sigma sp2 bond, whereas this is next hybridized orbital of this carbon which is overlapping with another orbital of next carbon. So this is the next carbon, and it is also having 3 hybridized orbital. So there is pairing is taking place. Because of that, this is sp2 sigma bond. In this case, there will be pairing is taking place with the hydrogen. Because of that, this is also known as sigma sp2 bond. Whereas this orbital of this carbon is overlapping with the next orbital of another carbon, and this is next orbital of this carbon. So these are the hybridized orbital of the next carbon. So what is happening in this case? This carbon will also forming sigma bond with this hydrogen, and there is pairing taking place between this carbon and this carbon hybridized orbital. Because of that, this pairing, this is also known as sigma sp2 hybridization. Further, what is happening? This carbon which is having 1 electron on this orbital, hybridized orbital, and also this carbon which is having 1 electron on this hybridized orbital will overlap with the next carbon. So by this is molecular orbital diagram. So if we represent the complete structure with the next hybridized orbital of this carbon, and this carbon another hybridized orbital is overlapping with this carbon hybridized orbital which is having 1 electron. So there is pairing is taking place. So because of that, these 2 hybridized orbital is having sigma sp2 bond. Further, there is one more hybridized orbital of this carbon which will be bonded by another hydrogen. So there is pairing is taking place. Because of that, this is also sigma sp2 bond. So this is the molecular orbital diagram which is represented by the benzene ring. There is one orbital which is left of each and every carbon, that is pz orbital. This pz orbital is unhybridized orbital which is not actually overlapping, and they are forming pi bond. These 3 orbital of the carbon are present in the same plane, whereas this unhybridized pz orbital is present perpendicular to the plane of these hybridized orbital of each and every carbon. It means one pz orbital is present perpendicular to the plane of hybridized orbital. This is one carbon 3 orbital, that is sp2 hybridized orbital. These are sp2 hybridized orbital which are present in the same plane. These are present in the same plane, whereas one orbital, that is pz orbital, which is having 1 electron, is present perpendicular to the plane of these 3 hybridized orbital which are present in the same plane. So this pz orbital is perpendicular to the plane of these 3 hybridized orbital. So what is happening in this case? In this case, there is 1 electron is present on these pz orbital, and 1 electrons are present in the hybridized sp2 orbital. So what is happening? This hybridized sp2 orbitals are forming sigma bond with the carbon, 2 carbon, next 2 carbon, and 1 sigma bond will be formed with the hydrogen. Whereas this p orbital, pz orbital, is perpendicular to the plane of these orbital. What is happening? There is 1 pz orbital which is perpendicular to the plane of these orbitals. So there will be formation of pi bond is taking place. So what is happening in this case? There is a formation of pi bond is taking place, that is both the lobes of this pz orbital is forming pi bond with the next carbon pz orbital. Similarly, in this case, there is pz orbital is also present. In this case there is pz orbital is also present. So both the lobes of the pz orbital, there is a formation of pi bond is taking place. It means these three hybridized orbitals are present in the same plane, whereas there is one pz orbital which is having one odd electron is present perpendicular to the plane of these hybridized pz orbital. If we represent the benzene ring by the help of bond lines, so what is happening? Every carbon present in the benzene ring is bonded by the 1,1 hydrogen. So what is happening in this case? We know that each and every carbon is showing sp2 sigma bond. It means sp2 hybridization. So there are 3 sigma bond are formed by the each and every carbon. So if we represent this carbon is forming 3 sigma bond, one with this carbon, one with this carbon, and one with hydrogen. So what is happening in this case? There are 3 sigma bond which are formed by each and every carbon in the benzene ring, and these bonds are present in the single plane. Whereas there is one more orbital, that is pz orbital. This unhybridized pz orbital is present perpendicular to the plane of this molecule. So these are the pz orbital which are present perpendicular to this molecule, benzene ring. So what is happening? There is 1 electron, that is single electron is present in the pz orbital. So what is happening in this case? This pz orbital will overlap with the next pz orbital of the carbon. So what is happening? There is weak overlapping is taking place from both the lobes, from both the side, that is upper lobe and below lobe. So there is formation of sp2 pi bond is taking place. Similarly, this carbon will also overlapping with this, and this pz orbital is overlapping with this pz orbital. So there is a formation of 3 pi bond is taking place in the case of benzene ring. So there is a possibility of overlapping of pz orbital can also takes place in this way. So what is happening in this case? This carbon pz orbital is overlapping with this. This can also overlap with this. So there is overlapping can also takes place in this way. Similarly, this pz and these two pz orbital of the respective carbon. So there is a formation of pi bond is taking place in this way also. So what is happening? There are two structure. In this case, the pi bonds are present in this position, whereas in this case, pi bonds are present in this position. So what is happening in this case? We know that this pi bonds are weak electron cloud. So what is happening? There is not actual overlapping is taking place. Because of that, there is a free electron cloud is present. So this free electron cloud of the pi bond, that is this structure of the pi bond, is overlapping with the electron cloud of the next pi bond. So what is happening? There is overlapping of a pi electron is taking place. Because of that, this structure can be represented like this. This circle is representing that this pi electrons are covering all the carbons which are present in the benzene ring equally. It means these pi electron cloud are overlapping with each other. Because of that, there is a cyclic ring is formed above and below the benzene molecule. Because of that, this pi electron is covering each and every carbon, that is 6 carbon is surrounded by these pi electron equally from both the side, due to which, because of that, the bond length which is present in the carbon in benzene ring was 139 picometer. It was intermediate to 154 picometer, which is single bond, that is carbon carbon single bond is having bond length of 154 picometer. Carbon carbon double bond is having bond length of 134 picometer. But in the case of benzene ring, these two bond length are not present. Instead of that, there is a bond length which is intermediate between the single and double bond. It means there is a partial double bond character between on each and every carbon which are bonded by the sigma bond. This pi electron cloud is covering all the carbons. Because of that, there is partial double bond character on every sigma bond which is found between the carbon and carbon. Because of that, there is no pure single bond, that is sigma bond, and neither there is a pure pi bond is present. The bond length which is present is intermediate between the single and double bond. Because of that, the bond length of the carbon carbon in benzene ring is 139 picometer. So this is because of the delocalization of these pi electron over 6 carbon which is present in the benzene ring. So because of the delocalization of these pi electrons over whole system of benzene ring, so nowadays benzene ring structure is also represented by this structure. In this circle is representing that these pi electrons are delocalized. These pi electrons are rotating and covering each and every carbon which is present in the benzene ring. It means these pi electrons are movable and delocalized. So next question which is arises in benzene ring, why benzene ring is highly stable, why it is not giving the reaction which is represented by normal alkanes. It is because of the resonance and delocalization energy. In case of resonance, particular molecule is represented by more than one structure, and these structures are known as canonical structure or Lewis structure. In these structure, the position of atom is fixed, only the electrons are moving in the whole system of these canonical structure. Individual canonical structure is not representing all the property of the particular molecule, whereas the combination of all the canonical structure which is represented by the particular molecule explain the property of that particular molecule, and this is a resonance hybrid, which is a combination of all the canonical structure. So let's see, in the case of benzene ring, how many canonical structures are formed. In benzene ring, there are two canonical structures which are represented, and canonical structures are represented by the double arrow. So in this case, there is double bond position in this way, whereas in this case double bond position is changed. So these are the two canonical structure which is represented by the benzene ring, whereas the final structure, that is resonance hybrid, is a combination of these two canonical structure. So this is represented as, this circle is representing that the position of the double bond is keep changing because of this delocalization of pi electron. This circle is representing that these pi electrons are rotating to all 6 carbon. Individual canonical structure will not explain all the property of the resonance hybrid, whereas the combination of these two canonical structure will represent the property of the resonance hybrid. Because of this reason, the bond length which is observed in the benzene ring, that is carbon-carbon bond length which is observed in the benzene ring, was about 139 picometer. It was intermediate between 154 picometer, which is single bond length, whereas a double bond length was 134 picometer. Whereas in benzene ring, the actual bond length was 139, which was intermediate between the single bond and double bond. It is because of the delocalization of these pi electron. It means there is a partial double bond character in each and every carbon which are bonded by the single bond. So because of that, the benzene ring carbon-carbon bond length is 139 picometer, and it is because of the resonance. The delocalization energy of benzene ring is 150.66 kilojoule per mole. Because of this much amount of energy, benzene ring is highly stable because of this much delocalization energy. We know that what is delocalization energy. It is the difference between the hybrid and most stable canonical structure. How the calculation of this delocalization energy will be done in the case of benzene ring? So if there is one double bond is present in this cyclic system, so what is happening? If there is one double bond is present, so in the presence of hydrogen, when hydrogenation, that is reduction of this alkene, is taking place in the presence of catalyst, that is nickel, temperature of the reaction is 473 to 523 Kelvin. So what is happening? There is a formation of cyclohexane is taking place, and in this reaction the energy which is released was about 119.66 kilojoule per mole. If we assume the hypothetical structure in which there is 3 double bonds are present and these double bonds positions are fixed. So if we represent a hypothetical structure, so if we represent the hypothetical structure, in this case, if the double bond position is not changing, then there is requirement of 3 moles of hydrogen. The conditions are similar in the presence of catalyst and this temperature. So there is a formation of cyclohexane is taking place, and the energy which will be released is a multiplication of this much of energy with 3. It means about minus 358.98 kilojoule per mole of energy should be released. Whereas in the case of benzene ring, when hydrogenation is taken place in the similar condition, that is in the presence of nickel, and the temperature of reaction is 473 to 523 Kelvin. So there is a formation of cyclohexane is taking place, but the energy, the actual energy which was released was around minus 208.36 kilojoule per mole, which was not equal to this much of energy which was released when we assumed that this hypothetical structure, in this hypothetical structure, there is a position of double bond is fixed. So what is happening in this case? We know that what is delocalization energy? It is the energy difference between the resonance hybrid and hypothetical structure. So what is the energy difference? So hypothetical structure is having energy of 358.98 kilojoule per mole, whereas actual energy which is released during hydrogenation of this benzene, so there is energy release of minus 208.36 kilojoule per mole. It means there is around 150.6 kilojoule per mole of energy is obtained, and this energy is used in delocalization. Because of the continuous delocalization energy of benzene ring is 150.6. because of that, these pi electrons are not easily available for donation, due to which benzene ring is not showing addition reaction, it is showing substitution reaction. Because of the similar reason, it is not giving test with the Bayer's reagent because of the unusual stability, and this unusual stability is because of the resonance and delocalization energy.